Hello, welcome back to Blender CC LIVENODING. In this episode, I'll be showing you how I created this artwork. So you might have seen the video. It's basically like a differential growth on a mesh happening here. So based on this algorithm, this is again, it's a scripted node light for SKETCHFAB, and Asahidari San made this algorithm that works with a scripted node light, and you simply just use it. Like in this case, not this one actually, yeah. So you just take a look at the node tree and yeah, just try doing it, and then you're gonna get the result. So this is the same thing, and I have this neon light shader that's using the layer weight. That's for you to try. Here I have like a simple default cube, which I subdivided it many times, and then I just simply decimate. So this is the cube. It's kind of like a middle resolutions, not too high because it might take a while. If you want to have like a high resolutions result, like even smaller details, you can actually try to scale the cube. So let's take a look at the node tree and try to understand what's going on. So this is the default cube. Again, if I go to edit mode, I have a bunch of points being selected. If I make changes, if I select just bunch of points here in order, just going in a circle, if I try to reload this, what's gonna happen now? Okay, let's see. Get selection, reload. Okay, now it's working. So it's if I try to make these steps 500 reload, it's gonna take a few seconds. While it's doing it, I will try to explain what's going on. So again, the process is gonna be, you select bunch of points in order. So these selections, actually 1, 2, 3, 4, 6, 7. Blender will remember the selection, get selections, and reload. So first of all, this node will grab the selected vertices, edge, and face. In this case, just the edge mask, and then we are using mask to index. Using list item node, we're gonna grab the edges and do the masking. And then there's a vertices and edge net to path, which is a little bit hard to explain, but once it's done processing, if you pipe this into this scripted node light, you're gonna get result. So there's all kind of result. I think in this case, we actually get some kind of mesh. So it's probably failing in this case. Let me try do something, just a simple triangle over there. Reload, get the cube, and reload. Wait a few seconds, and we're gonna get new result. This one is behaving a little better. Okay, so let's save this. This is actually working the way I'm gonna show you. Okay, I start with the default cube, and I'm gonna subdivide this. Simple. Apply with Command A. If we go to wireframe, okay, that's quite detailed. I'm gonna decimate and reduce this a little bit, so we have variations in the topology assigned. So let's save this very quickly as demo SNL diff cube, and I'm gonna reload. Actually, I'm gonna append node 3 from my previous Blender. So with the test phase, I'm gonna grab the node 3. Okay, so we have this phase 1. So I'm using my own face and then just do this differential algorithm. If we go to SKETCHFAB nodes, take a look at the node tree, we're gonna have the scripted node over here, I believe. Oh, we don't have. First of all, I will reduce this to 100. I'm gonna delete the face, select our box with the topology, select a bunch of points in order, maybe 1, 2, 3, 4. Get selections, and something is already happening. Okay, interesting. It's generating error there. We can try increasing this to 1000. So 1000 steps is gonna take a while. Based on the selected points, it's gonna do this differential growth. So basically the line that we selected, the points that we selected, it's gonna grow and gonna try to blend and live with each other without overlapping. So we get the result that's a little bit like this heart. This one by Jason Webb is actually really cool. There's a lot of theory explained here with differential growth. Just imagine this, but in a 3D surface, and we get that working for us automatically. Okay, that line is weird because our selection is probably a little bit strange. It shouldn't be overlapping. I think it really likes just a simple shape, maybe just this 4 rectangle. Get selections. Try again, 500 step, reload. It's a good read actually. Just gonna, sometimes it's, this shape is actually, this pattern is more interesting. The result is like actually very similar to reaction diffusions, but in this case it's working on the lines. Okay, like I said, this actually could take a while if you try to run it to 1000. This is 500 frames. Let me save this very quickly. You can actually try this on the donuts as well if you want to. Maybe I should do that. Let me try just for fun. I like to do it procedurally this way. And we don't have decimate inside SKETCHFAB, but we have remove double, so merge by distance. The resulting mesh will be quite similar. There, just triangulated mesh. So now we have this donut. I want to apply the same thing, differential growth. I will select triangle to start with, and let's see, get selections. It's already doing its thing. Okay, it's working. It's actually pretty fast. If you want something that's a little bit more detailed, actually if you scale this, I will scale this maybe this size. Okay, and then Control A, apply the scaling. Okay, it's complaining. Maybe in this case, just gonna, I cannot assign the apply. I need to select single user here, Control A, assign the scale. Now it's working, and just get selection, reload. I believe the reaction, the differential growth will look really different from the one that we have earlier. It's gonna be more detailed. It's actually taking much longer as well. Maybe if I try have another blender. Because the nice thing about SKETCHFAB is that it works on any version of Blender. Okay, this is what we have earlier. Maybe in this case I will just make it 1500, reload. This is, I think, a good size to run these calculations. This one is taking a while. Maybe I made the wrong selections. Let's just wait a few seconds. I actually tried this on a different object. I tried this on this Apple logo, but this is like the 2D version. It's better if it's like a 3D. It's gonna expand based on the shapes. Oh, I know what's going on. I made a mistake. I was selecting the wrong thing. File, save as. Delete the cube, get selection here. Let's try 1000 step. Actually, a better way in order to see what's going on is to to run Blender from the terminal. So if we run it from terminal, we have this progress status. So when we open the blend, it's actually running the calculations for differential growth, and it's gonna take a few seconds. It could take longer, you know, like a few minutes, even hours, if you're not careful. That's why it's a good idea to just redo this. Okay, this is actually doing 1000 already. So 1500 should be covering the whole thing. If I try to displace, I'm gonna make this donut a little bit fatter. And then I'm gonna enable post, and then save, reload. So this, it starts really fast and it gets slower after 50%. So this is when you take a break, have a drink of water or coffee. When you come back, you're gonna get some result. I believe if you use like a number module in Python, this will be a lot faster. few seconds more. Okay, done. So we have result 1500 frames. Actually, it's only 1000 frames. I forgot to change the number, but we actually have more detail because we make this torus a little bit fatter. If we test render, okay, this is using Eevee. If we use cycles, go look at the shader. Quite like this pink purplish with oranges. Maybe we can make it different. Lime green. Yeah. So this is a blend of two shaders. The green one and the glass. I think this is really cool shader. So yeah, so back to the donut. Sverchok. This time we want it to be fully covering the donut, so 1600 frames. Reload. Okay, so let's wait a few seconds. Let's have a read. Actually, there's one thing that I forgot to show you. Yeah, this one. Asahidari actually have another node set up that's allowing you to create this kind of flowery looking. This is actually more 3D. It's almost like a fabric. Something you want to try yourself, maybe if you are interested with that, this kind of shapes. You could actually just run this differential and then just extrude it out from the normal, and you get a similar pattern. That's quite beautiful as well. Yeah, mass growth and reaction diffusions. You can use this for a lot of things. You might even be able to create like a fabric, like a nice fabric. So just from this, you don't need to go like high details. You can just have like a simple shapes, and then just run this differential growth, and then use this to create a pattern that generates kind of like an armor, for like a character, because it's covering every surface quite beautifully, so there is no overlapping. So it's almost like a human muscle or tissue, if you think about it. So yeah, I might try that in the next video. So this always takes a while. Okay. Whilst doing this, I can open other app. DaVinci Resolve. Yeah, it's actually, I use this quite often recently. If you go to media, let's try to go to user, desktop. Gonna show you a render. Yeah, this one. So if you use DaVinci, you can just drag and drop it there. There's a few things you can do here. Just gonna show you. This is actually pretty cool to do an editing. You can actually bring some 3D there as well, but anyway, how it's going. 96. If you make the donuts larger, the pattern is gonna get smaller and the calculation is gonna take longer. $99, done. Okay, let's see if this actually settles. It's covering the whole thing. Yeah, not bad, right? So this is the result. I'm gonna save this. I will try to render this out using LuxCore or RenderMan. Let's see the results you're gonna get. It's quite nice. Okay, so that's basically it. Sorry about the processing it takes. This is the differential growth on Blender using Sverchok nodes. And thanks again, Asahidari, for this really cool algorithm that you made into scripted node light. So we can have this. You can try make your own fashion and then just use this. Yeah, try to make a fabric stitch, something like this. It's gonna look kind of nice. All right, thank you. Thanks again for tuning in, and I'll see you next time. Thank you. Bye.